So our next speaker is Andrew Johnson from the Eagle Lake Field Office, and he's going to be talking about evaluating post-fire restoration effectiveness using AIM data. Thank you, Andrew.
Hi, my name is Andrew Johnson. I'm a geographer up in the Eagle Lake Field Office, which is about 85 miles northwest of here, based in Susanville, California. I'd like to give a shout out to Steve Garman, who helped me with the statistical analysis for this presentation today. We're going to be talking about 2012 brush fire, our ESR treatments, and then utilizing AIM for monitoring treatment effectiveness. I see a lot of familiar faces in the room. How many people actually work on the AIM crew out there? Cool. It's pretty good spread. All right. So this is a pretty ridiculous picture, but it just kind of demonstrates, so this is me about 6 months after I showed up in Susanville in 2012. I'm from the Midwest, so I was pretty excited to see topography. And basically, I was working as a Chicago Botanic Garden intern, collecting native seed for the Seeds of Success program. And so for the next 3 months, we were collecting native seed for use in things like post-fire restoration. And then in a couple months later, the brush fire broke out, and we had to switch gears quite a bit, but was able to work on the actual treatment development, ground truthing, and implementation of the brush fire. In 2013, I went on to I worked as an AIM technician in Carson City and had the opportunity to return to Susanville in 2015 to work as a crew lead on the AIM emergency stabilization and rehabilitation monitoring for the brush fire. So I actually visit about half the points that I'm going to be talking about in today's presentation. So a little bit of our outline. First, we're going to talk about the brush fire background, then our treatment goals and implementation, monitoring design, our statistical analysis, results, and outcomes and lessons learned. So to get started on the background, I'd like to first welcome you to the Eagle Lake Field Office. Like I said, we're located in northeastern California, northwestern Nevada. We manage about 1 million acres of BLM land there. It's a pretty unique place. So our elevation ranges from 3,500 feet to just under 8,000 feet in elevation. Precipitation ranges from about 6 inches to 22. And it's really neat that there's about 5 level 3 ecoregions that converge right in Susanville. So it's the convergence of the Cascades, Sierra Nevadas, and the Great Basin. And it's also dominated by really rocky and heavy clay soils with like a young basalt parent material. So a little background on the brush fire. It broke out on August 12th, and due to already stressed resources resulting from multiple concurrent fires in the area, the brush fire spread rapidly. Overall, it burned over 315,000 acres. And one of the factors in this was that there were limited resources and historically low funding for suppression. Specifically, within suppression is our ESR, or our Emergency Stabilization and Rehabilitation, as well as low funding for recovery, which we call BAR. And so this fire burned about a third of our field off. So in 2012, this is a graph showing the DOI Suppression Budget for 2012, normalized by the acres burned. And you can see it's historically low. In the last 10 years, we've had at least $25 per acre. In 2012, we had about $8. And so a little bit of note on transparency in our results. Results of this analysis don't necessarily present positive results, but our focus is on using AIM for transparently reporting outcomes. This empowers decision-making accurately and adaptive management. So results and outcomes are specific to the brush fire only. So I'll go into our treatment goals and implementation. So our first objective from our ESR plan was to establish a vegetative component of native species. Our next was to establish and enhance sage-grouse habitat, followed out by establishing effective ecological processes and establishing a native plant community that's capable of outcompeting invasive species and noxious weeds. So our first monitoring objective from our ESR plan is essentially that greater than 70% of canopy cover is present for the rangeland ecological site when compared to a control area that is in a similar unburned ecological condition. You might be scratching your head. Additionally, our other one was that there was a presence of 3 seeded perennial grass plants per meter square and a half sagebrush per meter square, or about 1 sagebrush per 2 square meters. And so you may also be asking yourself, are these objectives SMART, or specific, measurable, achievable, realistic, and time phased? And the short answer is not really, but we'll see how that impacts our analysis later. So for our goals today, the goals for the treatments are to reduce annual grass cover and increase perennial grass and sagebrush cover, We identified aerial broadcast seeding by helicopter and rangeland drill seeding as our viable treatment types. And we located our treatments between 5,300 and 6,000 feet of elevation. And our drill seeding sites were located pretty much in any soil that was conducive to drill seeding. Since we're such a rocky area, it's really challenging to identify areas that can be feasibly drilled. So some of our seed source challenges. In 2012, there were 5 megafires. These are fires that are greater than 250,000 acres, which meant there weren't really any bear teams available for restoration. So all these projects were developed in-house and by people like me. Seed scarcity was a big issue. So in 2012 fire season was the 3rd most severe on record at the time. The brush fire was at the end of August. Funding was low. We ended up getting about a 1/6 of what we requested. The local seed was unavailable at the cost or scale necessary. Additionally, we have what's called the California Native Seed Policy that requires we use native seed in our restoration projects. So non-native seed wasn't really on the table. And additionally to that, there's not really any pre-emergent herbicides available in California that are cost-effective, just due to California's limited labeling. And further, while seed sources were matched as well as possible, the majority of the seed was from different seed zones. So this map here shows the burn severity overlaid with our treatments. The larger polygons are our seeding treatments, and some of the smaller polygons, which you can almost just see the outline, are drill seeding treatments. So real quickly, I'm going to go through treatment implementation for those of you that aren't familiar. The first thing you do is grab a bunch of 40-pound bags of sagebrush and grass seed, get those together, and start mixing them into the hopper, and load it up and drop it off over and over and over again. The next thing for drill seeding, you do the same thing, but start drilling it into anywhere that you've identified as a quality place to be drill seeding. And then you have to wait for a little precipitation. In this case, we got a little bit of snow filling up our drill rows, and then we got a whole lot of snow. But unfortunately, those weather conditions didn't really persist, and we entered a pretty severe drought in 2013. Some of those arrows are pointing out locations where our actual precipitation was much lower than the average. And the biggest factor is that we didn't really have much of a winter in 2013 or 2014. We had pretty much no snowpack and really high evapotranspiration rates during the summer. So a little bit of background on our monitoring design. We used a nested strata. We had a field office-wide sample draw. We then selected points in grazing allotments impacted by the fire. And so our no treatment control were the areas within the fire perimeter. We had an unburned control, which are points outside of the brush fire. And then we intensified our treatments within the drill seeding sites. So this was, within each drill seeding site, we had 3 sites per seed mix used. And then in our aerial broadcast seedings, we did the same thing, 3 per seed mix used. So this little GIF here is kind of showing our monthly sampling effort over the 3 years. And so within our rangeland drill, we had 12 sites. We had 15 within our aerial broadcast, 14 in our no treatment, and 29 unburned sites. So our overall ESR AIM methods, we use 50-meter transects, 55-meter plots. Our core methods were utilized in our supplemental methods, indicators of rangeland health and plant density, but for the purpose of this talk today, we're just going to be focusing on the results of line point intercept, which is our cover values, and our plant density, which is the number of species per square meter. So go into our statistical analysis. Our statistical approach or background, we had a little bit of background and challenges here. All of our points were randomly selected within each strata, which is great. All ESR plots were sampled for 3 years, from 2012 to 2015. Or 2013 to 2015, sorry. And we had a minimum of 3 plots within each seed mix and treatment type. However, this did not account for differences in ecological sites, which you may remember was one of our monitoring objectives. So we weren't really able to do that based on the sample design. But we additionally we had an unbalanced design across treatments and covariates such as ecological site and seed mixes. So to account for this, we used a repeated measures mixed effect model. Again, like I mentioned, the NOC assisted in this analysis, Steve Garman, the biostatistician there at the National Operations Center. We used a mixed effect model, which is conducive to this unbalanced design, and a repeated measures approach, which isolates the time variable and preserves the assumption of independence across sampling years. This However, though, we were still limited by the covariate interactions considered in the analysis, and because we had incomplete sampling across ecological sites and seed mixes. The indicators we assessed were annual grass cover, perennial grass cover, and sagebrush cover with an alpha of 0.05. Additionally, we looked at the density of sites compared to those benchmarks that I mentioned earlier. So results. Little note, all of our results are still considered preliminary. But you can see here the chart on the left displays the percent cover of annual grass by treatment type and year. The percent cover of annual grass is, by treatment type and year. Percent cover of annual grass is displayed on the Y, and the x-axis is the treatment type. There was not a significant difference between the annual grass cover of either drill or aerial seeding treatments and the unburned sites. And further, the rangeland drill seeding site had a significantly higher percent cover than the unburned control. So essentially what we're saying here is that there was no real difference from our treatment from natural regeneration, which is not really what you want to see. Up here, though, on the right, you can see that the annual grass cover increased annually across the board. So again, this graph's oriented the same in the bottom left, where we have our perennial grass cover on the y-axis and our treatments on the x-axis. And in this case, there was no significant difference between any of our seeded treatments and our unburned, our burned and untreated control and our unburned control. But again, the perennial grass cover did increase from 2013 to 2015. It's kind of coming out of that drought. So final one here is our sagebrush cover. This is oriented the same way as well, but with sagebrush percent cover on the y-axis. And while there's no significant difference between the seeded sites and the untreated burn site, there was a significant difference between all of the burn sites and the unburned control, and this is to be expected just based on the maturation rates of sagebrush. But you can see here that the rangeland drill site pretty much had 0% cover of sagebrush, while the aerial broadcast and the untreated site had about 1%. Next is the density of our seeded species. So in this monitoring design, we only measured the density of our seeded species and used the seeded species specific to each polygon. But again, these results aren't too exciting or less than exciting. Our aerial broadcast and rangeland drill seeded sites had, none of them met our benchmark of half of the sagebrush per meter square or 1 sagebrush per 2 meters square. And then for our monitoring sites, measuring the seeded perennial grass density, we only had 1 rangeland drill site that actually met our objective of 3 perennial bunch grasses per meter square on that plot. So our outcomes and our lessons learned. Based on our treatment objectives, seeding treatments were unsuccessful. Factors such as timing, drought, and seed source likely contributed. Subsequent objectives would be necessary to meet the current treatment objectives. Our discussion. So drought and seed source may have compromised seedling survival, especially in the lower elevation drill sites. Drill seeding should be approached tentatively, as seeding failure can increase annual grass cover relative to unburned sites. And if the treatments are outside the treatment window and local seed sources are not available, treatments should be considered apprehensively. And I think at the time we were much more, we're much more hopeful than we should have been in selecting these native seed species from so far outside of our range. Another thing I'd like to talk about is our lessons learned. So SMART objectives are critical to accurate reporting. Notice that our monitoring objectives it didn't really match, how we were measuring this, but they weren't really fully thought out. And I think a really key component of the AIM program is we've worked on developing SMART objectives at the beginning from the start and moving that forward. And since this was a pilot project, it was very early on and we weren't really wrapped into that process yet. So going forward, we've done a much better job of developing our objectives. But that was really one of the key factors compromising some of our analysis. Designing analysis and methods prior to implementation also ensures the monitoring design meets treatment objectives, It simplifies your analysis. It increases the ease of reporting. There's not that big delay. And once you said, oh, I've got this data, now how do I look at it? You can go immediately into your analysis and look at your results. So if your goal is a full factorial design, consider the number of covariates and sample a sufficient number of sites for inclusion and analysis. Like I mentioned, we didn't have full representation of our ecological sites or even our seed mixes, and so we weren't able to speak across different treatment types to those. Make sure to weigh the risks of treatment failure prior to treatment implementation and understand the likelihood of treatment failure and the need for subsequent treatments. So this was just kind of one example of the ways we're using AIM data in the Eagle Lake Field Office. It's really cool because, you know, all of those control sites, essentially, anywhere outside of our intensifications, and even the intensifications in certain circumstances, can be used for many other things. And so, for example, our land health evaluations for grazing permit renewals, EAs for wild horse and burro gatherers, the HAF, baseline and trend data collection, mapping invasive species and juniper, as well as helping us understand the state of our field office and look at the transition and assisting in state and transition modeling. So that, I'd really like to thank the ID team from the Eagle Lake Field Office. Without them, none of this would really be possible. And especially all the leads, technicians, and coordinators from the Great Basin Institute that helped collect all this data. You guys are the real champions. Alex over here was one of them. And I really appreciate all of that hard work everyone's put into it. Sarah McCord, Steve Garman, and the entire AIM team. So with that, do you have any questions? This is from a picture I found digging through the Rush Fire files. So that was during the seeding process. It's ridiculous. Not near our seeding, actually. They want to, yeah, but.
We have time for a couple questions. Do you have any data collected before the Rush Fire in that area? And have you looked at, if you have, looked at that
So we didn't have any AIM data. There is some really historic data, like SVIM data from the 80s. And we also have some of our upland health assessments, but the majority of those were pretty qualitative. There were some older methods for cover, predicting cover, but we have been trying to explore ways to compare those, but right now it's kind of that apples and oranges issue of looking between the two. And we didn't have much to any line point intercept data collected prior to this fire. That was kind of across the board. But yeah, exactly. If you look at these individually, there's not really any case where by year it doesn't go up within the individual treatments either, though. So it's just to different degrees. But yeah, definitely precipitation driven, I think. Yeah, so that's a really good question. Since this time, we've been working on a lot of things in the Eagle Lake Field Office to identify local seed sources and scale those up so that we can actually use local seed on the ground. We have been exploring a lot more with the available pre-emergent herbicide applications that we can use in California. A matrix is one thing that we can use. It's really expensive. This year was our first year with some major fires following the Rush Fire, where we've had some data to actually apply to these management decisions. And so we've been trying to spray, set up to spray herbicides, especially we have a fire in Nevada, so we can spray plateau there ahead of time, which is pretty cool. And we've been doing some studies with our local working group to identify the success of native grass seed compared to non-native grass seed in some of these really challenging areas that our soils have been compromised over the years and have already burned and we're in these repeated burn areas. So there's a lot of things we've been working on to try to get to that point. And the major takeaway is that we're much more apprehensive, I guess, with implementing a treatment if we don't think it's going to be successful. So, yeah. Anybody else?
skip a bunch of my talk. So you mentioned STEM and AIM. We're going to be covering that.
Awesome. Thank you. Thank you, guys.
All right.
Appreciate it.